Yeah.
Awesome. Hey, good evening, everyone. Thanks for joining today's session. Yeah, it's going to be a very exciting and interesting session because every day we hear some hacks or other when you wake up to the news, and especially if you're in the blockchain world. Security has becoming super paramount these days. So we have here with us Shantanu. Uh, we'll do the intros in a while. Shantanu is a smart contract auditor at QuillAudits. He will brief more about what QuillAudits is and what they have been doing in the smart contract audit space. Just to give a little bit of intro about myself, my name is Kiran. I'm the co-founder of Web3 Learn. Web3 Learn is a blockchain skilling platform. We help blockchain developers train. We teach them Solidity. We help them do the industry-ready projects, and eventually we also connect the developers to the industry. So we trained around 300 developers so far, and we had around 40 partnerships with various different companies across the globe. And one of the interesting courses that we are rolling out in collaboration with QuillAudits is the Smart Contract Audit course. Like I'll talk about those details at the end of the session on when we are rolling this out and the modalities about the particular course. But without further ado, let's kickstart the session. There's so many interesting things to discuss today. So welcome, Shantanu. Thank you so much for taking your time. It's a Saturday evening, I know, and I think it's raining across India. So
Yeah.
nice to be on a cool Saturday. Just to give a intro, guys, Shantanu, as I mentioned, is a smart contract security auditor at Quill Audits. I will let Shantanu introduce about himself and then also a brief about what Quill Audits is, and we will take it from there. Over to you, Shantanu.
Yeah, sure. Thanks for inviting me here. I work as a smart contract auditor at Quill Audits. At Quill Audits, we basically do smart contract auditing of the smart contracts that launch worldwide. There are a lot of projects that launch every month, and we basically ensure that there is a good security testing done of these projects, so that these projects don't get hacked. So yeah, the bugs finding and reporting them, that's what we do here basically, and helping the teams to fix that. So that's a very important thing. So I've been working here at Quill Audits for about a year almost. So yeah, it's been a great journey here. Yeah.
Super, super awesome. So since the title of the topic is building a career in smart contract audit, before even we deep dive into what a smart contract audit is, we'd like to touch base on your journey. So how did your journey to Web3 happen? And tell us something, tell us about your journey, and also why did you choose smart contract audit as a career path? I think there has been multiple career paths, within the blockchain space, right? Whether it is you can become a Solidity programmer, you can work in a DeFi space, you can build an NFT marketplace, which is super lucrative. But why did you choose smart contract auditing as a career path, and how did the journey and the transition happen?
Okay, sure. So it all began first I'll tell about how I began my journey in Web3. So it was my second year, and like every year we had in my college, we used to build projects. So there was one specific problem I wanted to solve regarding, say, the data problem related to a data. So it was a project in which we chose blockchain as the solution, go-to solution to build that project. So from there, I started to learn like very different aspects of this technology and the potential for this technology to solve a lot of problems. So that's what attracted me to this space. So I was also there into AI. So AI and blockchain both were my options, but specifically there are a lot of potential blockchain has to solve a lot of problems. So I started building a lot of projects, like hands-on projects in this space. Then I participated in hackathons, and I won this Chainlink hackathon as a runner-up, and that's what kind of made me jump into this space. And I did an internship in this space, and I directly started auditing after that. After the hackathon, I just jumped into the space directly after that. So yeah, that's in short, that's my journey there. Making projects, building stuff, hacking stuff, hackathons, building stuff, and kind of breaking stuff. Yeah, in this audits. Yeah.
Awesome. So I think you mentioned two important aspects, right? Building stuff and hacking stuff. You need to think like a hacker to even identify the bugs and how the particular smart contract can be broken. So let's divide the whole conversation back into two parts. One is you mentioned that you did a couple of hackathons, one hackathons, and then you deep dived into the space, right? From for the audience who are joining here today, if someone wants to start a career in the space, so what skill set do they need? Do they need to start understanding Solidity? What level of understanding they should have? Whether is it like a basic, intermediate, or advanced level? And what concepts they should be familiar within the smart contract, even before thinking about auditing the smart contract.
Okay. So in this space, I will kind of divide it into two parts. Firstly, the blockchain developers. What I think is that you should know blockchain development, Solidity programming before you start smart contract auditing, before you even enter into smart contract auditing. So why I'm saying this? So this is because you can think that smart contract auditing is one level deeper than this blockchain development, smart contract development. So I think that intermediate to advanced skills you should know in smart contract auditing. You should get to that level even before you think about going into smart contract auditing. So so there are a lot of nitty-gritties that people need to understand here. So like many of the universities, all the courses, all the computer scientists and engineers, that software engineers come. So basically they have a habit of programming in Web2 programming languages. So say C++ or C or JavaScript and everything. So the problem when you go into Web3 space is that a lot of concepts that you learn in programming in Web2 don't actually apply in Web3. Like it's a completely different system on which the code is running. Your code is not running on any centralized server. Here it is a complete different architecture on which your code is running. You need to understand how the blockchain works. You need to understand who are the participants. It's a dynamic system and you are actually programming money. So you need to be very careful as to what is going to happen here. Because a lot of decisions you make is going to impact at every step. So for example, say there are private variables in say C++. So when we use private variables in Solidity, so many think that, okay, this is a private variable and its value will not be visible outside this contract and stuff. But the problem is that this is a wrong assumption. On EVM chains like Ethereum, and obviously EVM on Solidity works on EVM. So on this, everything is transparent. Even private variables value can be read. So that's a huge mistake that developers can do here. So there, it's just like that. First, you need to understand development so that you don't make silly mistakes while auditing. And once you understand that, you can go even deeper into how the EVM work. EVM is nothing but Ethereum virtual machine on which your smart contract code runs. So which are the EVM chains? Almost like the most popular ones, the Ethereum, Binance Smart Chain, Polygon side chain, Avalanche, all these support EVM. So it's always best to start learning Solidity if you want to go into this space.
Awesome, awesome. So you're saying intermediate to advanced level Solidity programming is required, and you need to understand how an EVM chain works. So let's take Matti, step below, like in a little dig deeper. So what sort of concepts one should be familiar with? In terms of say. What we teach at Web3 learners, people start writing about smart contracts, the basics, variables, creating functions and calling functions, etc. and all, right? So if we're talking about the auditing, I'm purely kind of trying to understand here from a pure developer perspective. Within Solidity, when you mean by intermediate level, what are the like 1, 2, 3 prereqs one should have to get started, even to start looking into or auditing the smart contract?
Can you repeat the question once? Yeah, the
so,
last part.
So something like what are the topics that one should be familiar with? We know at a 30,000 foot level, intermediate to advanced level, Solidity is required, right? But within the Solidity, what are like 1, 2, 3 topics that one should be good at, for them to even pick up the smart contract audit?
Okay, so so firstly, according to me, you need to understand the various standards that happen. So basic is okay. You will understand the basics, the types of variables. You'll understand how to send Ether to smart contracts, how to withdraw Ether, how to program with Ether. That's almost everywhere you will be able to understand. Like the Solidity documentation is also very good. But then you need to understand what are ERC20 tokens, what are ERC 721 tokens, how the DeFi applications are made. There is a lot of interconnectivity between smart contracts. Like there is one smart contract inherits another smart contract. The smart contract interacts with another smart contract, and there is a whole interconnected stuff that happens. So you need to understand that. Then also I recommend that you need to understand testing. So the testing of functions. So that's a very important thing. Unit testing is what basic you should focus on at the start. I am saying unit testing means nothing but what are the parameters that are getting passed into the function. Is it really expected? Are these results expected? Like you kind of test those test cases, call this unit test cases. So after that, you can step up to functionality testing, which is similar in a kind of similar, but kind of test every function in every kind of possible manner. You try to break those function after that. So the blockchain smart contract developer is expected to know unit testing, and it's a very good plus if you know Truffle, you know Hard Hat. Remix ID also is a very good interactive way where you can run your code, and then you can move on to kind of the functionality testing of stuff. And then when you enter into smart contract auditing, it's then expected that you learn various attack scenarios. So there are a lot of common attack vectors, like there is re-entrancy attacks, there is denial of service attacks, and how kind of you should kind of study like what is the history of these attacks.
Yeah,
That is like
I was just about to come to that. I know that's kind of the next topic. So you made an interesting point. So a deeper understanding about the different standards, and then how to write a unit test and a functional test, executing it and ensuring that the test results are on the lines of the expected results. So that is at least the minimum basic requirement, and a little bit of expertise in that space is required, for someone to start, getting into the auditing part, right? Now, within audit, as touched just now, there are certain standards, there are certain vectors, there are, like, I think, a decent number of them, where each one has to understand what is a reentrancy, is all about, right? There are like multiple aspects, multiple vectors that are out there, in the smart contract audit. So when someone is starting the smart contract audit, like, how should one progress? Is it like, are they going to learn one at a time and then start looking into the smart contract and then thinking from that angle to start with?
Yeah, like I personally think that you should study these attack vectors one by one, because this is that cannot be understood if you don't focus on them well, one at a time each. Like, for example, in reentrancy, there are different types of reentrancy, so you need to understand that as well, and you need to understand the patterns that come in this kind of attacks. Like, even in the kind of denial of service attack, even the example you might study, when you go to the smart contract, it can be a different scenario. Like, the example may not look like how it was there, but when you see at the business logic and stuff, it would be a completely different way to hack it, but it would be still a denial of service attack. So you need to brainstorm a lot in kind of what exactly these attack vectors mean, and how are the various possibilities in which these can be achieved here.
Interesting. So my next question is, so one reads through this different vector, goes deep dive. So how should one become an expert in that, right? We always believe in that, practicality is the more important aspect, So I think people should be aware of, like, what are the attacks that are happening each and every day in the blockchain space, or the DeFi space. DeFi is part of blockchain, in the blockchain space, and should they keep track of what are those attacks, and then circle back to the vectors that they're learning. Oh, you know what? I think this is how this is why this particular attack has happened. There is a flaw in the smart contract, and if possible, if there is a GitHub code for that particular product or the protocol, go back to the smart contract and then find out, okay, hey, this is what we have learned, and I think this is what exactly has happened, and now I can see why this particular hack has happened, right? So that's kind of like what I think through that could be the best learning mechanism for anyone to learn the smart contract auditing. So my question here, on the top of that now is, the space is evolving at a very faster pace, right? I know we have a certain set of vectors, that are coming up in the market, but are they going to be sufficient, right? How should one think through and develop a sense of that hacker thought process, and then ensure, okay, there is a checklist of these 25 vectors. Okay, the smart contract exactly fits well. Okay, the smart contract is considered to be safe, but might be tomorrow there might be the 26th vector or some sort of a new thing that might come into the picture, right? So my question is, when someone is learning the smart contract audit, wearing that hat, what sort of thought process that they should develop, apart from the technical stuff, to think through in a longer term, or to think through out of the box, properly from a hacker angle, to say that, okay, hey, might be this could be a possible scenario that might happen, might be, let's start working or looking into that, right? So how do folks do that? What is like the best practice to achieve that?
Yeah, I think that's a very good question you asked here. this is one of the most important things that white hat hackers should develop, a kind of hacker mindset. And obviously this can happen only when you do practical stuff. You need to really go there and hack stuff. Like there are various practical examples. There's Ethernaut, and there is damn vulnerable DeFi where you can do this stuff. But this hacker mindset, which you're talking about, I personally think this can be developed when you think about this scenario, that if you don't kind of hack this project now, like you are doing the ethical hacking, right? If you even miss a certain bug, you need to understand the impact. Like I say in the last month, there was this Harmony Protocols bridge hacked for about $100 million. So like even one bug can destroy the smart contract. And there is this inverse finance hack that happened. It happened for the second time. It had happened before also, but it was hacked the second time in the last month or this month, if I'm not wrong. It was about $1.2 million. So it was this attack vectors, which you see here, they kind of evolve at a very fast pace. So you need to kind of keep updated as well. So if you don't find the bug, the black hat hacker will kind of get there first after you. So you need to take a time and kind of think through the various perspectives in which the smart contract can be hacked in order to ensure that funds cannot be stolen from here. So that mindset every individual needs to develop in himself.
Got it. Okay. So we'll take maybe a couple of questions here. So Priyanshu is asking, okay, I think we have one more question before. So Wasim, was asking, what are the best measures these smart contract developers needs to take for contract security? I think we briefly touched on most of those aspects at the moment. So Wasim, let me know if that helps. Not if there is another specific question, happy to take it to Shantanu. So Priyanshu is asking, what are the audit tools that you are using at the moment and why?
Yeah, audit tools. Actually, there are a lot of audit tools out there. So the first and foremost is what I recommend is manual testing itself, like the testing that we humans do ourselves. Why I'm saying this? Because this space is so new that even the tools have not been evolved. So think like Ethereum out there came out in 2015 or 2016, and DeFi has been like smashing through every year. It's like at rapid pace, everything is getting developed. So even the tools are not that mature to kind of see these things through. So you need to focus a lot on manual testing itself first, because a lot of bugs will be found out in that process itself. After that, there are automated tools, obviously, you can use. There is Mithril you can use, there is Slither you can use, then there is a lot of like for debugging and stuff, you can use Tenderly for that. Etherscan is obviously there for seeing the transactions. And yeah, like Consensus develops a lot of tools as well, so you can also check those out. There's also fuzzing out there that do those testing. So Echidna is there, and yeah, there are a lot of tools out there, but I recommend manual testing first to really go there and kind of dip your hands in that. Yeah.
Awesome. Okay. I think I wanted to touch on this topic, and Francisco asked a very interesting question. So have you ever worked on Algorand projects? What do you think of the platform? So might be I'll add my question to that as well. So how does the smart contract auditing vary from chain to chain, right? Like for example, like Ethereum smart contract auditing vis-a-vis Solana, vis-a-vis Avalanche, vis-a-vis Near, right? How different and difficult it is to audit these different smart contracts on different chains. And two questions there are: what are some of the transferability skills, across all the smart contracts on different chains? And if someone wants to audit smart contracts on different chains, do they have to start learning different sort of stuff as well? So maybe we'll pick up that first question, have you worked on all around and what do you think of the platform? And we can go to these questions.
Okay, so what I think is personally, I am my expertise is in Solidity and EVM chains. So if you the EVM on which the Ethereum works, it's the same EVM on which Binance works. Okay, so the same concept will get applied there. But when you go to Solana, which is obviously Rust based, there is a completely different sort of things you need to understand there. It is a Rust programming language. There are a lot of different kind of architectures, and even the what we say, the names of various different things are different there. So you need to understand that, but you need to see that everything starts from Ethereum first. Okay, so Ethereum is kind of the king here. So whatever gets made on Ethereum, similar kind of stuff will be made on other chains. So this is the effect network effect, if I'm not wrong, it's called. So even on Solana, when you will go there, you will see this, all those swaps like Uniswaps. There are various things there. So the kind of way in which this protocol works will be similar. So, but it will be coded in a completely different language. So yeah.
Interesting.
Even Near, I guess, is yeah.
Yeah, Near is also a non-EVM chain at the moment. So you're saying start with Solidity and Ethereum chains, non-Ethereum chains, have little more complexities than the EVM chains, Okay, interesting. So the next question I think is similar to what we had before. Are there any auditing tools which automate the checks of do's and do nots? Okay, I presume the question was around there are like this different set of vectors there. Are there any tools that say, okay, hey, here are these 15 stuff that you need to look into a smart contract and then give a check mark so that the smart contract passes through the audit? Do we have any tools like that?
Yeah, sure. There is Slither, you can say, for example, that does check various standard attack vectors. I guess there are 150 or so, or 100, close to 100. So it does check that. But even when you run Slither, you kind of need to check whether really it's is it not a false positive? Does it really exist? You cannot really trust it 100%. So again, manual testing. You need to see that manually. So yeah.
Love the word, false, alarm there, right? Yeah, they might say, okay, the audit is good, but the contract is good. But see, guys, I think at the end of the day, it's not like a typical Web 2 testing, right? Even if there is a bug in the code, something like in an ERP system, what might happen, the max that could happen is it will break the system and we'll have a downtime of that particular product. But we're actually talking about money in smart contract, right? So you need to be super and extra cautious. One bug, and I think it will wipe out millions of dollars. We're not even talking about hundreds of thousands. Yeah. So one follow-up question, that D is asking is, the real formal verification. Okay. Any tools for the real formal verification of the code itself? Okay.
I think
from the from are there any kind of auditing tools which does the formal verification of the code itself?
I'm not sure about the formal verification, but in the testing itself, there are a lot of tools. Like, for example, if you want to test manually, you can kind of semi-automate that manual testing by writing these tests in as various like certain language which covers various scenarios. Yeah, you can do that. There are tools. and yeah, like obviously you need to check the business logic also, like very properly, because something you might be thinking is expected, but it might be unexpected there, or even either way can happen. So yeah, you need to do that as well.
Interesting. So primarily, you can rely on automation or the tools, but trust your instinct. I think always human intervention, keeping that eyes and ears on the smart contract is the paramount thing. That is where you find most of the bugs. Yeah, I think you doubled it down on tech multiple times now. So guys, please remember that. So the next question is from Priyanshu. He's asking, how much is really important for the people who are just learning the pitfalls and vulnerabilities? And if then, what is the best resource for learning UL by UL?
For learning Yule.
Mm-hmm.
Okay, so for Yule, actually there are various resources. I cannot say there is one best, but like obviously there is the documentation itself. I guess there are books on that as well, but the thing is you need to keep updated every time, because it can obviously change in any EIP. If something changed, you need to understand that as well. So yeah, so no single. I don't think we should just see like a single thing. There might be something that single resource might miss out, which may be there in some other resource. So yeah.
Right. Okay. So this is a very interesting question. So D is asking, do you test only the functional or logic behavior, or do you also have to test the robustness against various race conditions? I think the question is more around like what sort of aspects of smart contract do we need to test? Um,
I guess that we need to test those race conditions as well. Like there can be scenarios where this can happen. So if you are smart enough, I can say, you might be able to figure it out from looking at the design pattern itself. But again, you need to be sure, you need to practically kind of write, say for example, a proof of concept, or to actually ensure that does this really happen or not. You cannot always assume that this bug exists. You need to also write sometimes a proof of concept in which you write a kind of a test condition in which you are actually carrying out that exploit, and verifying whether it exists or not. And some example scenarios can be a good stuff to kind of do that. But that is actually a very advanced level of question. I think you need to kind of get to that level to do that. But yeah, that's the thing.
Cool. Okay. Harshit has asked a very interesting question. I think that this is going to be a long answer, but we'll take it at a 30,000 foot level. How do you start an audit? How do you actually start audit of a project from start to end? Might be let's touch on various steps that are involved at a very higher level.
Okay, at a very higher level. So you can visit our website, obviously, at QuillAudits. You can try it out. You will understand that on a very high level, we kind of tell you to give like details about your project. We verify those details, and yeah, we start those testing, all these testing things, and really hacking. We'll try our level best, like even better than what we can do to hack your code, and find out these interesting bugs and reporting them. And yeah, then you can go and fix these, and That's it, and we will re-audit if it's really you have really fixed your code or not, or have you not fixed it, and there will be the final report, which will be stating everything in the report. Yeah.
I think I'd like to add two things there, Harshit, right? So it all depends on what is the outcome that you're looking to achieve. Based on the outcome that you're looking to achieve, the steps might vary in a smart contract audit. I know you are trying to understand from the process perspective, but do you want just a audit at a very higher level, or first of all, like which vertical are you building in, right? So for example, like the DeFi smart contract audits are very robust. That requires a deeper level of understanding, that requires a deeper level of thorough auditing, because as I mentioned before, we are talking about money. But imagine if you are doing a smart contract audit for a DAO, that might be equally robust, but like not as robust as what a DeFi smart contract requires. So it requires a different set of processes and the steps involved. I think as Shantanu mentioned, check out the QuillAudits website. I just put it on the chat box. If you still have any questions, reach out to me, and I'll be more than happy to connect you with Shantanu and the QuillAudits team for further clarification. So we'll take 2 to 3 more questions, and then we'll do the final comments. So Sher is asking, does Web2 bugs exist in Web3? It's an interesting question.
Okay. Web2 bugs exist in Web3. So this might be a very, very unique thing about me, perhaps, because I directly jumped into Web3. So I'm not exactly that much aware about these Web2 attack vectors, you can say, but obviously denial of service, the denial of service exists in Web2. So it also exists in Web3, but the way to carry it out will be completely different, right? And yeah, so that's the thing about it. If you want to kind of learn about these attack vectors, so there is kind of hashing bits, which is a newsletter which we do every week on Substack. So you can check it out, in which we cover various projects that have been hacked, how they have been carried out, and so that you can learn from these, and it cannot happen again. Yeah.
Like I think he just added it's something like SQL injection and XSS, So do those sort of bugs exist in Web3? Have you come across?
Okay, so I got your point. So a simple example. So for example, we can say the $600 million hack. So this was of Axie Infinity. So Axie Infinity game got hacked for $600 million, and this is a Web3 project. So how it got hacked? So I believe there was phishing was done to kind of get control of the victim's machine, and kind of compromise the validators on which the Ronin chain was running. So even if the smart contracts, they do run on blockchain, other stuff, they utilize Web2 kind of frameworks on which these run. So where there is centralization issue, Web2 attack vectors happen. Obviously, they can happen. So more than 30 to 40% attack vectors, I believe, come from Web2 itself, which happen on Web3, because Web3 is not exactly completely kind of disjoint from Web2. It utilizes the technology of Web2 as well. So you need to understand that as well. Like Discord can get hacked. So Bored Ape. So so it starts from there. So anything is possible here.
I think that's a great point that you mentioned, right? The Web2 and Web3 are not living in an isolation, there is always a lot of connectivity. And I think we, we are still at Web 2.1 or 2.2, right? There hasn't been complete decentralization that has been achieved. Even we are not at 2.5. There is a long way to go, but that's a great point. So, Sher, I hope that answers your question. So we had like one last question, but we touched on that. Simple path to smart contract auditing. I think that's what we've been talking for about like last 45 minutes. That should summarize everything. Cool. So thank you so much. I know we're exactly right on time. One more question. Sorry. Yes. Okay, we'll take this question and then we'll wrap. So if we look at the big recent hacks, the root cause allowing hackers to succeed was not bugs in smart contracts, but bugs in the protocol. Interesting. So anyone aware of how to assess and audit the governance and the risks associated with it?
Sorry, can you repeat the last line? Anyone aware?
So primarily, like how to audit the governance. So DE, is that like the governance and the assessing the risk at the protocol level? Is that what you are trying to ask? Okay, cool. Yeah, at the protocol level.
Okay. So obviously, if you can take the example of the recent, I guess, inverse finance hack. So at the protocol level, you can say there was the price manipulation that happened. There was flash loan attack. So if your kind of project or Oracle is kind of susceptible to price manipulation, I guess that's what the protocol level bug you're saying it. So here actually, when we do a flash loan attack, so there are multiple kind of protocols that get used in this. So you need to kind of take those into consideration as well when you kind of do auditing of these projects, because as you can see, a lot of flash loan attacks happen and governance level
I think that's a great point. But like I think his question was like how do we even assess it, and how do we know that like there are bugs that are even existed at a protocol level itself, right? So we might develop an application believing that okay, that protocol is very robust and strong, in the anticipation that the security standards are set at a very high level. But like when we start building an application and then when we put the application out, if even though we write a very robust smart contract, there are these vulnerabilities at the protocol level. Like how do you even control them, right? Like
okay.
I think that's kind of his question, which is very interesting. Like there are two parts to it, right? Unfortunately, we are building on an existing infrastructure that are being provided by these protocols. It's not that we are building something in isolation. So are there any best practices as of have you come across those instances, and like how to kind of solve those sort of stuff?
Yeah,
Because
sure.
I'll like if there is a hack that happens in this instance, I think the onus lies not on the application developer or a smart contract developer or an auditor, but I think the protocol has to take the onus and then say, okay, hey, the mistake is mine. Unfortunately, this is why it has happened. Of course, we're not trying to find solutions, but like from the technical perspective, like how do we resolve this?
Okay, sure. Like this is actually a very realistic question, like important question here. So I will give you an example. Some of the projects that were made, I guess in Solidity 0.4.0 and 0.5.0, at those into consideration, these kind of attack scenarios might happen, and in future this happened. So what best practice which we suggest as a company is that you get your code audited from at least two different kind of auditing companies, and you also do a bug bounty. So a bug bounty kind of ensures in the long run that you are incentivizing the right kind of hackers to kind of find bugs in your projects. I think that's the best practice which we recommend to follow in order to kind of solve this issue.
Cool. I think that's a great point. Bug bounties. Yeah. Awesome. Okay. Cool. On that note, guys, thank you so much for joining. As I mentioned at the start of the session, we are rolling out an exclusive secure smart contract auditor course in association with QuillAudits. I put in the links in the chat. Join us, our community. There is a QuillAudits website there, and subscribe to their emails, and also our website web3learn.io, where you can actually register for the upcoming courses there for the waitlist. We'll keep you posted once we finalize all the modalities. This is going to be a very rigorous, intensive course to learn smart contract auditing. And the interesting part, I don't want to ruin the surprises, that will be released, but this course comes with a placement. If you are doing extremely good, and if you are in the top 4 or 5 candidates, that are coming out of the course, there are a couple of smart contract auditors who are looking to recruit you, and one of them is QuillAudits, actually. So it's going to be super exciting, and we are like more than excited, to roll out this course with one of the best smart contract auditors out there in the market. So on that note, thank you so much for joining. Thanks a lot, Shantanu, for your time as well. It's a wealth of information. And one more note, we will be sharing this recording in the next 24 hours. We'll put it on the YouTube, and then also we'll share it over your email, so that for you to actually go through in case if you missed any specific points. On that note, have a great evening, have a great day, guys, and have a good weekend as well. So we'll talk to you sometime very soon. Thank you so much.
Yeah, thanks a lot. Yeah.